Okay, Algebra 1 students, here we go, Section 3 for direct variation. And we will talk about writing and solving problems that involve direct variation. And it's very similar to slope in certain ways, and then there's a few differences, and I think we'll see as we go through. So direct variation, it's an equation in the form of y equals k times x. Y equals k times x. And it has a constant rate of change, k, and that's called the constant of variation. So one thing to think about here, like we talked about an equation in the form of y equals kx, so you'd see something like, for example, y equals 750 times x. Okay, let's say it was, say, dollars and cents. Let's just put a dollar sign in there, like dollars per hour. So your k value would be pay per hour, and that's a constant amount. You're going to make that much how many hours you work, and your x value would be your hours that you worked. So it would be constant. You're always making $7.50 per hour, and the more hours you work, the more money you would make. And if you worked, say, 0 hours, you wouldn't make any money, because $7.50 times 0 would be 0. So that's like an example in that form. And that k is a constant rate of change. It's constantly going up by 750. So that's very similar to what slope was when we talked about that in our last lesson. So there's a constant rate of change, and always goes through the origin here. So it's always going to have a point 0, 0. So it's going to start at 0, 0, meaning, again, like we talked about, if you worked 0 hours, you would make 0 money. And say you didn't do 0 homework, maybe you get 0 grades, or 0 A's. I don't know what it is, but think about that. You're always going to have a point 0, 0 in which to start with. Okay, so it always goes through the origin. So let's get a practice problem here. It says find the constant of variation for each equation and compare it to our slope. So when we look at the graph here on number 1, we try to find, and maybe it's tough to see right away. Let's see if I can highlight it for us. Right here, here's the graph of that equation. Y equals 1/2 x. So y equals 1/2 x is the equation. So our k value, that's what we're trying to find, the constant of variation. Oops, I'm sorry, 1/2 x. 1/2 x. Okay, so we're trying to find the k value, which is our constant of variation, is the number in front of x. So we're trying to go y equals, we're trying to find constant of variation, which is k, and the equation is, remember, y equals k times x. So in this case, our k value here is going to be equal to 1/2. Okay, so that's that part. But now let's compare it to our slope. So we know how to take slope a couple different ways. So we have the graph here. So let's just use rise over run. We have this point here, and we have this point up here. So let's go with the rise. 1, 2, 3. So we are going a positive 3 because we're going up. And now we're going to go from this point over to our second point up here at 6, 3. And we went 6. And going 6 to the right is positive. So for our slope, we had a slope of 3 over 6. And we're not going to write that. Obviously, we can reduce that to 1/2, or 1 over 2. So you notice our slope would also be 1/2. So a key point here is that, k and m are the same measures. And I start that are the same measures. Okay, and we put a star by that one, so they're the same. Your k variation right in front of it, the x there was 1/2, and when we found the slope by the graph, it was also 1/2. Okay, so now let's take a look at the next one, number 2. Name the constant of variation for the equation y equals -2x. Then find the slope of that line that passes through these 2 points and compare them as well. So we look at the equation, the constant of variation. Remember, constant of variation is k. So it's not a very good circle. So right here, our k value, we can see it right away. That's the easy part. We can see that it's y equals -2x, so our k value is -2. And then for slope, we're actually going to use the slope formula here. So let's just go ahead and say, this is our x1, y1, and this is our x2, y2. And then we could find our slope using the slope formula. And we could say m equals y2 negative 2 minus 0 over x2 minus x1, so 1 minus 0. And when we do that, negative 2 minus 0 we know is negative 2. And 1 minus 0 here is a positive 1, and so we know that reduces to a negative 2. So our slope is also negative 2. So again, we show our k value and our slope are the same at negative 2. Okay, so pretty simple examples there. All right, let's talk about graphing a direct variation equation. So a couple steps to this. The first thing we're going to do is we're going to write the slope. That's also k. We kind of proved that on the last slide as a ratio. And then we're going to start at the origin, because remember, all these go through the origin. And just a reminder, our origin is 0.00. And then we're going to use our rise over run to plot more points, or we can use our slope. That's m, rise over run, to plot some more points, and we're going to connect the dots here. Right? And last but not least, obviously, connect those dots to make it a line. It's a linear function, it's constant, so we're going to have a line there. Okay, so let's start here with this question here. Graph y equals negative 6x. So in this case, we can say, y equals kx, because it's in that form. And so we know right away that k is equal to negative 6. And we also know that our slope then, with rise over run, would be negative 6 over 1, because if we read it as rise over run, sorry, let's back that up real quick. So we know our k and our slope are the same, so our slope would be negative 6. But let's say we wanted to write it in like rise over run fashion, so when we graph it, it becomes easier. What would negative 6 be as a fraction? Well, it would be negative 6 over 1. Because remember, we got k equals m right here, so we know those are the same. So when we graph it rise over run wise, we can use negative 6 and a positive 1 for a rise and run. All right, so the next point, we've got our slope, we're ready to go. We can start at the origin. Okay, so starting at the origin, and what I'm going to do is I'm going to go, my rise tells me to go down 6, and then my run tells me to go to the right 1. So when I plot this point, starting at the origin, I'm going to go down 6 spots, 1, 2, 3, 4, 5, 6, and then over 1 to the right, because right is positive. Okay, and I'm going to run out of room here, so I can also go the opposite direction, and I can go up 6 and backwards 1, because the same deal, if I go 6 over negative 1, it's still equal to a negative 6 slope. So I can go up 6 and left 1, 2, 3, 4, 5, 6, and to the left 1, and now I've got a graph that goes kind of both directions. Let's put a line through that. Best I can here. Ugh, I don't like that. Let's back that up, try that again. There we go. I'm just going to go the other way to get another arrow on it. Okay, so that you can see is our graph. Okay, and again, I started at 0, 0. I went down 6 over 1, but then I went the other direction, up 6 and to the left 1, just so I can make it linear, because I could fit those spots on each graph. Okay. All right, I'm going to skip number 4. I think that is your practice problem. I think. I'm not sure, but if not, we can do it in class. All right, so the concept summary, not much to cover here. We've already kind of talked about this stuff here, but we've got a direct variation where their equations of the form y equals k times x, where k is not equal to 0, because if it was equal to 0, then the whole thing would be 0. Because anything might multiply by 0 is 0. We talked about that earlier. The graph of y equals kx always passes through the origin. And if the slope is positive, then we have a line that looks like this. And it's positive if k is greater than 0. So remember, this is your greater than sign. And over here, the slope is negative if k is less than 0. Just remember, reminder, your greater than, less than signs. Okay? All right, next up, we're going to write and solve a direct variation equation. So writing and solving direct variation equation. So the first thing we're going to do is we're going to start with the direct variation equation. We know that's y equals k times x. Okay? And then there's two different spots. We call it first half and second half. So the first half here is find k by replacing x and y. And then we're going to write a new equation there. Okay, write a new equation with those numbers. Okay, write a new equation. And that's the first half of it. That's the first half. So we'll draw a line here. And that is our first half. It's the first half of the problem. Break these into two halves. And our second half over here is then to use your new equation to answer the question. And that's the second half. We break these into two pieces. First one, we're going to use our y equals k times x equation. And then we're going to replace x and y with some number they give us. And then we'll write our new equation. And then the second half is using our new equation to answer the question. So it might be easier to see it worked out. Okay? So let's try this one. Suppose y varies directly as x. And I know that's a tricky wording of a problem. But suppose y varies directly as x. So we're going to write a direct variation equation that relates x and y and then solve. Okay? So let's start with our first half. First half. So first thing we're going to do is we've got y equals k times x. That's how we're starting. Okay? And notice there's a comma here. So right where the comma, and we're going to try to have commas all the time. So we'll draw a line there that we will break it up into first half and second half. So we know, all right, this is the first half, this is the second half, so we know what we're working with. All right, so y equals k times x. So they give us if y equals 98 when x equals 14, then the rest. But let's just focus on that. So if I plug in 98 where y goes, because y equals 98, so if I plug that in, and x equals 14, if I plug that in right here, now my equation is 98 equals k times 14. Okay, so that was the first step, but I want to solve now for k and then get a new equation. So I'm going to go ahead and divide by 14. Divide by 14. And I'm actually going to just show you that in a different color because I like to do that. Just to show you that we're actually doing the work there. So we divide by 14, and we get a nice even answer of k equals 7. K equals 7. Okay, but if we go back to the last slide said, right here, start with that equation, and then find k by replacing x and y, and then we're going to write the new equation. So we're still going to write it in this form, y equals k times x, but now we know what k is. So now we're going to go ahead and write our new equation to say y equals 7x. So we're still writing it in the form y equals kx, but now we know what k is. So that is our new equation. It's our direct variation equation. So now we're going to bring that over to the second half. Bring that over to the second half and solve this problem using our new direct variation equation. All right, so here we've got find y when x is equal to -4. So we want to find y, that's right here, when x is equal to a -4. So now if I use that equation that I just came up with, that I brought over to the second half, y equals 7x, now I can plug certain things in. So my y, I don't know what that is, so that's going to stay here. But my x, I can definitely plug in over here. And so now I just go y equals 7 times x, which is 7 times a -4. And so y would equal a -28 there. Okay, so if you had to back that up and rewatch that, I know there's a couple different things that happen there, but we've got our first half and our second half. And we'll do another example to kind of show you how that works. It's just first part, getting the y equals kx, solving for k, so then you have a new y equals kx equation, and then you can solve when they give you one of the variables. Okay? All right. Number 6, you can work on that on your own, or maybe we'll try this in class to see where we're doing, but it's very similar to that one. But I want to try number 7 here. Number 7, if y equals -11 when x equals 6, find x when y equals 44. So again, our comma is right here. So let's draw the line for the halftime line. Let's say this is the second half. Okay, second half of the problem. And then over here, we'll do the first half. All right, so we start with y equals k times x. And we can sub different values in. Okay, remember, we've got a y is negative 11 that I can sub right in there. I've got an x equals 6 that I can sub in here. So I'm going to rewrite that equation. It's going to be, instead of y, negative 11 equals k times 6, right? Because 6, I'm just substituting that in. And now what's my next step? I've got a negative 11 equals k times 6. Well, I want to solve for that k so I can write a new equation. So how would I solve for k? I'm going to divide by 6 here. I'm going to divide by 6 here. Now this one's not going to turn out as friendly. We know these 6 will cancel out. So the right side's good. We're going to have k. But the left side, we've got a negative 11 over 6. And we're just going to keep it as negative 11 over 6. And that's fine. So our new equation then in y equals kx form would be y equals negative 11, 6 times x. First half is done. Now I'm going to pull that over to the second half and use it for my next part of the question. So this is find x when y equals 44. So once again, I'm starting with y equals k times x. But in this case, I already know my new equation. So y equals negative 11, 6 over x, or times x. And from there, now in this one, they're asking me to sub in y. So I've got y equals 44. That's going to go in here. My x is what we're trying to find. So be careful with what they're looking for. Are they looking for x or are they looking for y? So now I'm going to substitute this y in here at 44. So that's going to give me 44 equals negative 11, 6x. And now I have to solve for x. Well, I'm being multiplied by negative 11 over 6. So what do? We have to divide. Or, in the case of fractions, we multiply by the reciprocal. So I would multiply by negative 6 over 11. I got to do that on both sides. Negative 6 over 11. So we know that's going to happen over here on the right side. It's going to cancel out. On the left side, we've got some tricky math we can do. And I'll let you guys kind of figure out that math there through here. But what you should end up getting is x equal to a negative 24. With reducing, we know on the right side these 6's are going to cancel, the 11's are going to cancel, and you're going to be left with x. But on the left side here, you could multiply that out, 6 times 44, and then divide it by 11. Or you could cross-multiply right here with 11, or cross-cancel with an 11 and a 44, and figure that out. But it does come out nice and neat to negative 24. Okay, so I know that was kind of a long one, but our lesson summary today is how are slope and constant of variation related? How are the slope and the constant of variation related? And then our practice problem here is if you worked for 6 hours and earned $31.50, what is your hourly rate? So basically, what is the K value? You worked 6 hours, you made $31.50. What is the K value? What is your hourly rate? Okay, and we left some questions undone, so maybe we'll do those in class tomorrow. But other than that, bring any other questions you have, and please ask them and be ready to go as we get to work on this section. Thanks a bunch. We'll see you tomorrow.